So we're working on circles. We have the center radius form of the equation of a circle. And it's pretty darn easy if you have that equation written with the parentheses to find that center and radius. Change the sign, square root. Now, it's not quite so trivial if it's not written with the parentheses. Then you have to write it with the parentheses. And the way you do that is this process called completing the square. Okay, where we rewrite the x's as a perfect square trinomial, and the same thing for the y's. And the way you figure out the number that you use in order to get a perfect square trinomial, you take half of the unsquared number, the variable that isn't squared, half of this number, and then square it. 10 squared, half of 10 is 5, 5 squared 25. Half of 14 is 7, 7 squared 49. Half of 6 is 3, 3 squared 9, and so forth. And we've done 2 problems where we go through that process, and we're ready to do problem number 10, but I wanted to make some observations that this first number here in front of the x squared should always be a 1. And why should that be? Well, here's this equation right here. If we actually FOILed out x minus h squared, what would you get? You'd get an x squared. You're not going to get a number in front of the x squared, just an x squared. I guess there's the number 1, okay? So, on problem number 10, which is what we're going to do right now, it says, find the center and radius of the circle. I'm going to do this just to make sure it doesn't time me out. Okay, so we're doing problem 10. Let me make it larger. And let me write it down. This one's going to have one extra step that the other ones that we've done, 8 and 9, didn't have. Problem 10. 5x squared plus 5y squared minus 50x minus 30y plus 150 equals 0. And here we don't have to do any graphing, it's just a multiple choice one, okay? So, let me move this down, and let me lock, not zoom, where's that focus button? Lock the focus so that it isn't doing a constant zoom attempt to focus there. Okay, well, on problem 10, we need it to just look like 8 and 9 with an x squared, not a 5x squared. So that's the most basic problem-solving strategy there is. If you know how to do it when there's not a number in front of the x squared, then let's just make it look like this one here by dividing straight through by 5. So I'm going to divide straight through by 5. So we have x squared plus y squared minus 10x minus 6y plus 30 equals 0. Have we made it look like 8 and 9? Yeah. So do exactly what we were doing there. Complete the square. We'll group the stuff together. Let's see. Grouping the x's together. We'd have an x squared, then a minus 10x, and then I'll put a plus blank, and I'll do the y squared. So y squared minus 6y plus blank equals a negative 30 plus a blue blank and plus a red blank. So, what number goes in the blue blank? What am I going to do? Did I hear 25? That's right. How do you get it? You take half of this number and then square it. So I'll take half of 10, that's a 5, and square it, 25. That's what goes there and here. Now, what about over here? What's going to go in this red blank? 9. Half of 6 is 3. 3 squared is 9. If you want to say half of negative 6 is negative 3, once you square negative 3 times negative 3, it's still just going to be 9. That's why I only mention half of 6. I don't worry with the negative. Okay. So again, I'm taking half and squaring it. That's what goes there. Now, there's a step that I wasn't showing a while ago. I want to show it here. I'm now factoring this blue stuff the way we would factor, since the beginning. You go x and x. Second sign is plus, so 2 of the first. And what number goes here and here? A 5? See, I didn't show that step a while ago when I did 8 and 9. I just jumped straight to that step, the x minus 5 squared. But is it clear? I was actually just factoring it in my head. Right here, I'm not going to show that step for the y's, but what am I going to have? I'd put a y. Is it going to be a plus or a minus? What's the next one? A minus, that sign right there, and then 3. This variable, that very next sign, y, second sign is plus, so 2 of the first. And then the square root of 9 equals, what number is 4? Okay, yeah. Let's see, 34 minus 30, yeah, 4. So are we now ready to say the center and radius? Oh, yeah. Ready to do the change the sign, square root. So what's the center? 5 and 3. And what's the radius? 2. Square root of 4 is 2. Now, before I punch that in, I want to make a couple of observations. There's a couple of special cases that we might see as we're doing these. Here's special cases. If we had gotten the radius to be a 0, if this 4 had been a 0 instead, would we really have a circle? Can y'all picture a circle with radius 0? You wouldn't really have a circle. What would you have? If this had been a 0. The radius is 0. You have a center and a radius is 0. You don't have a circle. You have just a dot or a point. So if the radius turned out to be 0, it would just be a point. And here's another tricky special case. Suppose this number on the right had turned out to be negative 4. If this had been a negative 4, the square root of a negative number is an imaginary number. If that happens, no graph exists, not even a point. Just no graph at all. Okay. So, and those special cases are, oh wait, there, sorry about that. If R is 0, the graph is a point. if r were the square root of a negative number. In other words, instead of this 4, if we'd had a negative 4 over here. You can't have a radius of 2i. Would it make sense to talk about a radius of 2i, an imaginary number? So that's why there's no graph at all. And we're going to see some of these special cases in a moment. But let's go ahead and, oh wait, I don't have to do anything other than just click. What was the answer here? A, B, C, or D? B? Yeah. Oh wait. Oh, let me make it a little bigger. Maybe we're through with those where we have to graph them, in which case I can make it a little bigger like that. Yeah. Okay. So B, let me check it. Okay. Oh, let's do another one of these. This one, maybe I did make it too large. Starting with number 11, the instructions change. It says, decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, describe the graph. I sort of dislike those instructions because it makes it sound like you're just supposed to look at the equation and decide, is it a circle, is it a point, is it a line, is it non-existent? Really, the only thing you can do by just looking at it is say it's not a line. Okay? With lines, there can't be any exponents. And since there's exponents here, the answer is definitely not C. I've never seen it regenerate where it is C either, okay? Where it's a line. But lines have no exponents. But to decide on everything else, you've got to literally wait until that last step. At the very last step, when you're doing this, calculating the radius, that's when you decide, oh, it's a point, or no graph, or else it's a circle, depending on whether you're getting a real number, non-zero number for the radius, or I should say a positive number, a 0, or an imaginary number. Right? So don't let the instructions scare you too much. It's still the same stuff. So let's do number 11. Let me write it down. X squared, let me make it a little bigger. X squared plus y squared is number 11. Hey, we don't have to divide through by anything like we did on number 10. We had to divide through by, what was it, 5? Okay, so we're going to go through those same steps. We're going to try to write it with those parentheses. So I'll group the x's together with the blue plus blank. And I'll group the y's together with a red plus blank equals, I'll move that 25 over, so it's a negative 25. And just to try to help me remember that I need to put those numbers on each side, I'll do that. And I've got the hang of figuring out the number that goes in the blank. I'm going to take half of this number and then square it. Okay? So I'm taking half of 10, that's a 5, and then square it, so 25. So 25 goes in both of the blue blanks. What about in the red one? Okay, you take half of this number, I'll write it out in words, and then square. 9 is what I heard, and I agree with that. Half of 6 is 3. 3 squared is 9. So let's try to factor these x's. Notice I'm not writing out the two parentheses. If you want to, that's fine. So it'll be an x, and say it again. Plus 5, that's right. This variable, that sign, square root of 25 is 5. Now what about the y's? Y plus 3, is that what I heard? Because that is correct. Y plus the square root of 9 is 3. And what number do we have on the right-hand side now? 9. So can we do change the sign, square root? Well, let's see. The center would be a -5 and a -3. Change the sign, and the radius is 3. Do we have one of these special cases? No. Okay? If the radius had been 0 or an imaginary number, then we'd have one of those special cases. So, let's see, which choice will I choose? Well, I'm going to choose this first one, and I'm going to have to make it a little bit smaller so it'll fit better on the screen there. The graph of the equation is a circle. Notice we couldn't exclude the point or the non-existent until we got to this step right there. If that R had been 0, you'd say point. If it had been a 3i, an imaginary number, you would have said non-existent. But you don't really decide that until the very end. So make sure you're putting this in parentheses. -5, comma, -3. You got to type an ordered pair. If you don't type an ordered pair, it's going to count it wrong. And the radius of 3, let me make it a little bit smaller. Oh, hard to see. Let's say check that answer. We'll move on to another one. Any questions there? On number 12, it has those same options. Point, line, non-existent. Well, since there's exponents up here, all you can say is definitely don't say it's a line. If there's an exponent in the equation, it can't be a line. So let me write down number 12. X squared plus, let me blow it up for y'all. We can see it a little easier. Plus y squared plus 6x minus 8y plus 29 equals 0. So x squared plus y squared plus 6x minus 8y plus 29. Okay. So here we go. I'm doing the same thing I did up here. Oops. Notice we didn't need to divide. I think number 10 is the only one we have to divide something. Okay, right off. So I'll group the x's together. X squared plus 6x and put a blue plus line. Then I'll do the y squared and a minus 8y with a plus blank. And I'll move that 29 over here. Plus blank. Plus blank. Well, I need to write out how I find the number in the blank. What am I going to do? Half of 6 is 3 and square it to get a 9. There. Then we'll do the same thing with 8. Half of 8 is 4. 4 squared is 16. Okay. Okay, so this would be an x and a plus 3. Carry down the x, carry down the plus, square root of 9 is 3. What about the y's? It would be a y minus 4 equals, negative 4. Normally I find the center first. So my habit is to work left to right, change the sign. But maybe I should make a habit of always doing the radius first, because what are we getting is this radius? What's the square root of negative 4? It's an imaginary number. That can't happen. If your radius is an imaginary number, you don't even have a circle. Okay? There's no graph at all. Okay? So because of this, no graph exists. Not even a point. So, I'm going to make it a little smaller. You click the graph is non-existent on number 12. I think everyone's number 12. Well, I'm not going to guarantee. I'm pretty sure it's going to be one of those special cases, either a point or non-existent. But I'm not saying definitely everyone's is non-existent. There might be a point on that one. I'm hoping the next one is going to be a point, but let me see.
There was no need for a center coordinates.
No, you didn't need the center. There's not even a point there. Okay? If it's a non-existent, then you don't even need to punch in that center. You only punch in the center if it's a circle. And in order for it to be a circle, that radius has to be a positive number. It can't be 0 and it can't be imaginary. So, one more of these. I'm almost sure 13 is the last one. Yeah, 14 is absolute value, cut point thing. So 14 and 15 are a review problem. So here's the last one. Problem 13. Let me write it down. X squared plus y squared minus 4x minus 10y plus 29 equals 0. Oh, let me make it bigger. You're trying to write it down. Okay, let's group the x's together first. Oh, let me get started. Grouping the x's first. All right, x squared minus 4x plus a blank. And I'll do the y squared minus 10y plus a blank equals negative 29. And then that's a blue blank and a red blank. So, okay, let's complete the square on the x terms. What perfect square am I going to put in this blank? 4. I take half of 4 is 2. 2 squared is 4. Y'all caught up? What perfect square will I put in this blank? 25, half of 10 is 5. 5 squared, 25. So instead of doing this first, I noticed something on the right-hand side. This number over here, negative 29 plus 4 plus 25, is that just a 0? So that means the radius is 0. So it's not really a circle. What is it? Just a point. And if you're curious, what is that point? Well, it's complete over here, but it doesn't ask you for that. It just says it's a point. Now see why I'm not doing this stuff here? Once I realize that R is 0, then this is a point. Over here, once I see I have a negative 4 up here, I didn't need to do any of that. Because the radius is an imaginary number, so no graph. As soon as I see that the radius is 0, I can stop and say it's just a point. Okay. Let me see. Oh wait, no, not there. I'm going to come over here. And let me make it small enough so we can see all the options. Oops, still not showing. The graph of the equation is a point. You just click there and call it quits. Okay. So 14, 15 are cut point problems. Any questions there? If there were no exponents. Okay? For it to be a line, there can't be any exponents. And I've never seen them regenerate to be a line because there really wouldn't be anything to do then other than click it's a line. So if there wasn't an x squared plus y squared on it, then it's a line. Okay? Now, let me get out of this. I think most, I'm posting whatever I'm writing, I'm scanning and putting it here under document sharing. Let me see. I also use this right here. I'm about to post under document sharing also this little handout which just sort of summarizes everything I've said today. Way back before I could record everything I do, I had little handouts, little PDFs that it used to be leaflets that I gave paper copies of. But this sort of summarizes how to go through and do that completing the square. I'm writing it out as a sequence of steps. Divide by 2 and then square, add it to both. If you want to read through it. Step number 8, to find the center, change the sign of the number of the parentheses with x, then change the sign of the number in the parentheses with y. To find the radius, take the square root. If r is 0, these are the special cases. It's not a circle, just a point. If r is imaginary, no graph, not even a point exists. And so this is a handout I typed up years ago before I had the videos. It's now obsolete, really. But if you want to see what we were doing here as a recipe, how did I do number 11? What are the steps? Then that's what this little thing is right here. And it's about to be under document sharing. It will show under your document sharing right now. Okay? So, if there's any questions, I'll try to answer them. Otherwise, what should you be working on? Well, hopefully you've done assignments 1 through 10. Okay? And if you're going to do the extra credit, it's getting down to the line for it. So And by do it, I mean it's all or nothing. Either you do it and make 100, or you don't bother doing it, because it's only, you get the extra points only if you make 100. Okay? If you have any questions, I'll try to answer them. Otherwise, I will see y'all on Wednesday when we do lesson number 11. This is the 7th week. It is time is flying by.